Okay. If no more questions about that, we're going to go ahead and go into the lesson today. A couple of things we're going to talk about here. We're going to start with a single phase transformer. And if you need to reference back to it in the book, it's very short in the book. It's on page 338. And I'm fixing to share my screen again. I'm going to show you a couple of videos on a single phase transformer. And if you guys remember Professor Shoemaker talking about it a right good bit, the parts of a transformer, we talked about the primary winding coil coming in, and it wraps around the core, which is made out of maybe soft iron or some kind of steel, and it's a laminated steel core. And then it goes to the other side where it's induced, the voltage is induced over to on the secondary side on the secondary coils, so you can get your secondary voltage out. That is the basic transformer that's in the field today. I got a very good video I want to show you guys. Hang on one sec. It's only a few minutes long. Let me share my screen again with you guys. And I'll be going back and forth between a couple of videos with transformers, and we're going to talk about auto transformers. But I mean, stop me at any time. I'm going to stop this video as we go through it and kind of point out some things, what I've dealt with in my career. If you have any questions about it, guys, just like I said, just speak up and I'll pause the video. All right, here we go. Everybody got that? See transformers?
Yep.
Here we go.
Transformers come in a variety of shapes and sizes, ranging from the very large to the very small. Now, there really isn't much difference between the job done by a large substation transformer and the job done by this small transformer. When it comes right down to size or shape, transformers do basically the same thing.
Now, I'm going to pause it right here a minute because I want you guys to look at the difference of this transformer and what we've been talking about on the field. What do y'all notice? Anybody notice anything different about this transformer than any of those other ones we've been dealing with?
Only has one bushing.
One bushing, that's right. And just like on the transformers on the poles out on the yard that you guys been changing around, if you look at the bottom right, you'll see a little lug kind of near the bottom of the tank. It's got a piece of wire coming off of it. You know, just like the transformer we looked at on the field where it comes in one bushing, goes through the coil, and it comes out the top. Well, down at the bottom on that tank ground is the other end of that winding. Instead of coming out on the bushing, it actually comes out on that tank ground and bonds to the pole. That's really no difference. You get the same voltage out that you do with a two bushing transformer.
A transformer that changes voltage from lower values to higher values usually referred to as a step-up transformer. Step-up transformers are commonly used in transmission systems. In a distribution system, however, you're most likely going to find step-down transformers. That is, a transformer that changes voltage from higher values to lower values. In this part of the program, what we want to do is give you a basic understanding of how transformers work and teach you how to recognize the typical types of transformers you'll find in distribution systems. We'll use this simplified diagram to identify the basic elements in a transformer and to explain how transformers work. In general, the transformers you'll find in distribution systems have three elements in common: a metal core, a primary winding and a secondary winding. Voltage is applied to the transformer through the primary winding and taken off the transformer through the secondary winding. When voltage is applied to the primary winding, the resulting current creates a magnetic field around the core that induces a voltage in the secondary winding.
A question.
Between
Okay.
the number of turns in the
Pause.
primary winding.
Go ahead.
Okay, so as far as the core is concerned and the secondary and primary windings there, are they insulated from the core or are they making physical contact with it?
Yes, that's a good point. These are not making contact with the core. That laminated core is covered in like what do you call it? Some kind of insulating property, like a paper, or it's some kind of real-like property that insulates it from the windings coming in.
So only the magnetic field is going through and not electricity.
That's right. It's not anything touching. It's all induced voltages. Voltages applied to that primary coil. You got those lines of flux that go out, and it uses magnetism to those lines of flux to put voltage over on the secondary side, on those secondary windings.
Thank you.
You're welcome. Any other questions, guys?
Winding and the number of turns in the secondary winding determines whether the voltage induced in the secondary has a higher or lower value than the applied voltage. In most distribution transformers, the voltage induced in the secondary winding is lower than the voltage applied to the primary winding. In this example of a step-down transformer, one end of the primary winding is grounded. A tap coming off the center of the secondary winding is also grounded. This results in one primary lead coming into the transformer and two secondary leads, plus a ground coming out of the transformer. We'll use this simplified illustration to show you how the basic elements are arranged in a typical pole-top transformer. You can recognize this type of transformer by the cylindrical housing, a large primary bushing on the top of the housing, and three secondary bushings on the side of the housing. This illustration is similar to the kinds of transformers you see on many overhead distribution systems. Both the primary and secondary bushings insulate the transformer leads as they pass through the housing. The primary winding in this transformer is supplied with primary distribution voltage from a distribution line on the poles. Primary voltage is applied through this lead that runs through the primary bushing to one end of the primary winding. The other end of the winding is tied to the transformer's housing, and an external ground is applied. The secondary, or utilization voltage induced in the secondary winding, is tapped off the transformer through leads that pass through the secondary bushings on the side of the housing. In this example, the lead passing through the middle bushing on the secondary side is grounded. The leads on either side are hot. The secondary leads are usually connected to wires that form a secondary bus, which supplies consumers with electricity through service drops. Here's a typical pole-top transformer. Let's identify the elements that allow you to recognize this component as a transformer. First, it has a large primary bushing on top, connected to a distribution line. Second, smaller secondary bushings are located on the side of the housing.
Let me back that up in 1 second to that picture, guys. I'm just going to point out a little something to you here. On this picture here, if you can see my cursor, on the secondary side right here, it is what he talked about it being grounded in the previous slide. And right there, you can see in that picture, the little small picture in there is grounded. At Duke, this is the way we used to ground the neutral bushing. We would take it over out of the top and go back around and ground it back to the system neutral. Well, they've actually done away with this and came out of the bottom. And Professor Shoemaker at Santee Cooper, they call these jug leads. And we'll talk about this more when we start into transformer banking. But these leads is this actual secondary lead out of the neutral bushing on this transformer is taken back up. It'll go down around to the side and back up. But the construction specs have changed on this with Duke now. This neutral is no longer at the transformer level. It's actually 4 inches up. It's dead in it or straight through 4 inches below the tank ground. So it's no longer needed for this neutral bushing to come around from the top. So we just drop it straight out of the bottom and tie it back into the line neutral on the bottom. Just for your information.
Okay, and while you're still sitting there, Professor Vermelin, you know, different companies have different techniques. Santee Cooper does not use these types of transformer, obviously by the ones you've seen out there at the field. This transformer, and you just looked at it in your previous quiz, you've got to have a complete path both on the primary and secondary sides for you to be able to get voltage to flow. So some companies use this technique of the secondary neutral makes the complete path for both primary and secondary. Santee Cooper doesn't do this. It uses a dual primary bushing scheme. So you have a path for primary and a path for secondary that are separate.
Right. Years ago, before we became Duke, this was much like what we used in the field. This transformer is a single bushing Csp transformer. Csp meaning completely self-protected. This transformer here actually has a breaker inside on the secondary side, and you can see the little handle sticking off the side. And that was before we put fuses, primary fuses above the bushing on the primary side. And what we did with that, if there was a secondary fault, it would actually be more like a breaker in your home, and it would automatically trip that breaker inside. Say secondaries got together, squirrel got on the secondaries, got them together, whatever, car backed into the pole, slapped them together. Then when we got there, only thing we had to do is just like we took the stick that you changed the fuses out, there's a little eye on the side of that right there, and you push it up, it'll reset just like a breaker in a house, and then you pull it straight down to come back on. And it would let you know if the fault was still on the line, if you didn't clear that fault, especially if you were working with open wire secondaries, they were still together. Of course, they would be slapping together down the line. You'd see a bunch of fire flying down the line. Or if it was a bigger internal fault, I have seen where when you close it back in, it would blow the top off of this transformer. You know, and that had to be a really catastrophic fault inside for it to do that. But anyway, I have seen it done like that. Duke Energy does not use these transformers anymore. And there's still a lot of them out in the field on the Duke system, but we have taken those out, or we started taking them out and using just single bushing transformers with a fuse above the primary, on the primary side. And that's the way it's been for years. And another note, even with, I'll say not with that, but on the single bushing transformer like Santee Cooper uses, you know, the conductor comes in on this side, goes through the windings on the core, comes out the top on this side, and goes to a pole ground. The problem, I say it's a problem, I have seen it before, but I've seen guys go out, change out transformers, and forget on a single bushing transformer to connect this ground back to the neutral or the pole ground. And if you do not have this connected back, then you could have, we use 13,200 volts. You might have 13,200 on this tank right here. So you had to be very careful with your checks before you energize these transformers to make sure that this was connected to the pole ground. But I've seen a hot tank on the pole. How we knew it was hot would be people calling in and say, hey, y'all got a transformer up there and the pole is smoking where it's at, and it's just, going to ground through the hangers instead of on the pole butt ground. So just be mindful of those things. You've got to be aware of those things when you're, re-energizing, replacing transformers, those kinds of things. I'm gonna continue on with our video.
Connected to a distribution line. Second, smaller secondary bushings are located on the side of the housing. Finally, the wires coming off the secondary bushings form a secondary bus and service drop going to a customer. Now that you have a basic understanding of how transformers work, and you've seen a typical example of a pole-top transformer, let's look at some other examples of transformers that you may encounter on the job. This is also a pole-top transformer. It looks and works exactly like the one we just discussed, except instead of one large bushing on the top of the housing, this one has two.
All right, guys, let me ask you a question. This is like what we've been working with on the field out there. On the other part of the video, let's see if you can see this picture. All right, you see that bushing on the left-hand side is actually onto the primary. Now, in the picture here, you'll see the primary is connected to the right-hand bushing up here. Does that really matter if the voltage comes in on this side and you energize it this way?
I wouldn't think so, no.
Okay. Professor Shoemaker, question, if you're still there. He's gone. Guys, what we used to have on this, and I'll show you that in a minute when this video is over. We'll take a break when this is over, and then I'll show you about the difference with the
What was the question?
If I put primary voltage on the right-hand bushing on this single-phase transformer, is it going to change the direction of flow inside that transformer?
It will. It'll flow from left to right to left, and if you put it on the left-hand side, it will flow left to right. But remember, AC is bidirectional.
Yeah. Okay.
So really, it doesn't affect the secondary.
Okay. Thank you, sir.
Thank you.
This bushing allows the primary lead to connect to the primary winding, just like we saw earlier. However, instead of having the other end of the primary winding grounded through the transformer housing, this type of pole-top transformer is grounded through this second bushing. Both single bushing and two bushing transformers perform the exact same job. They just look a little different. In some cases, the load demand and equipment used by a consumer requires the use of a three-phase transformer. In an overhead system, 3 single-phase transformers can be connected together to form a three-phase transformer. Of course, not all transformers are located overhead on utility poles. In areas that have underground distribution systems, pad mounting is a common method of installing transformers. This three-phase transformer is housed in a rectangular-shaped metal cabinet that sits on a concrete pad. All connections for the transformer are concealed within the cabinet. Single-phase pad-mounted transformers are similar in shape, but their cabinets are usually smaller in size. Inside the cabinet are the primary bushings and the secondary bushings. Somewhat less common, but still used in many underground distribution systems, are subsurface transformers. Subsurface transformers are installed underground in specially constructed vaults for protection. In shape, subsurface transformers resemble single-phase pole-top transformers. However, both the primary and secondary bushings are usually located on the top of the transformer housing. So far, we've looked at various examples of transformers found in distribution systems. Earlier in your training, you saw several examples of substation transformers. Substation transformers are usually rectangular in shape and mounted on concrete pads in a substation. Their primary and secondary bushings are usually located on the top of the transformer housing. Substation transformers are much larger than pole-top or pad-mounted transformers. The reason for this is that substation transformers are designed to handle higher voltages than distribution transformers. Substation transformers are easy to recognize because they're always located in substations and they have large bushings. Transformers are a very important part of a T&D system because they change the value of voltage and current to meet the specific needs of the system. In this portion of the program, we've given you some basic information about how transformers work, and we've shown you some typical examples of the
Hey guys, that's basically how a transformer works. You guys got any questions or comments about what you saw in the video or anything that we've talked about so far this morning or in the past few weeks about transformers? No? Okay, well, let's go ahead and take about a 10-minute break, and when we come back, I'm going to bring up the drawings and some drawings, and I'm going to, kind of just draw some things out maybe to make it a little bit easier for you. But go ahead and take about 10 minutes, and I'll see you back here about 10. All right, guys, it's 10 o'clock. Let's get started back. Is everybody back? All right,
Yeah, I'm here.
good.
Yeah, me too.
Here.
I'm back.
Okay, we'll go ahead and get started. I'm gonna share my screen one more time. We're gonna finish this up with this single phase Elijah. Okay, he's back. All right, we'll finish this up. I'm going, like I said, I'm gonna share my screen one more time here. I'm on my Wacom here. I'm gonna just draw a couple things out for you guys. Can everybody see that drawing of the transformer I got here? I'm just gonna run through this kind of quick and let you get your eyes on it, and then we'll move on to one more thing before we end the lecture this morning. Just if you guys want to jump in and just tell me where things go, that's fine too. We're going to start on the primary side, and we're just going to keep it just like what we're working out on the field. You're going to start off on this side. Let me and you can see P on here, right here. P designates primary, N designates neutral, and these will be your voltage wires here and here. And when we get into transformer banking itself, we'll actually change this up a little bit, not to confuse anybody, but we'll actually put the neutral down on the bottom when we start banking. Okay, so anyway, we come in at the primary. On the primary side, we'll have a fuse on it. We'll come into top bush and left-hand side. The windings go through the transformer, through the core. And remember, it does not touch the core. That's a laminated core, so nothing is actually touching. It's just going to be induced. And this will actually go down and tie back to the neutral or ground. Everybody good with that so far?
Yes, sir.
Thank you. We're going.
I did have one question, sir. You keep using the term banking. I don't think I've heard that one yet.
You haven't? All right. Give me a minute. Let's finish this up, and then I've got another drawing here on banking, and I'll show you what we mean by banking, okay?
Okay.
All right, now, secondary side. We've got a winding that comes off this side in this direction, and we've got a winding that comes off this side in this direction, okay? Everybody knows that the middle, this is, what will we do with this middle bushing right here on the secondary side?
That's the neutral.
To the ground.
Neutral, ground, yep, it all ties together. We'll tie it right here on this bus work, okay? And also, just like on the transformer on the field, this one, the tank ground is also grounded as well, okay? All right, like we talked about, primary comes in and it's flowing. And remember, it's alternating current. It's back and forth, but it's going to be flowing in this direction, and it's going to be inducing. It's going to have, those flux lines going all the way through it this way, and it's going to cause induced voltage onto the secondary side. When it does, you're going to have a flow this way, and it's going to flow out of these secondary terminals on this side and flow down to this side. Somebody tell me what my voltage is going to be from here to here.
120.
20. And from here to here.
120.
Okay. And then from phase, the phase is going to be what?
240.
40.
240. All right. Now, is it going to be the same down here between here and here? What's that voltage going to be?
120.
Be the same, right?
It'll be the same. 120, 120, and then I'm sorry, phase to phase will be 240. Okay. I mean, that's pretty simple, right, guys? And then,
Yes, sir.
yeah, and then when we get into the transformer banking part of it, this is what you're gonna. This is just gonna be how you're gonna label things. Okay, so you're gonna be dealing with 3 phases of primary. You're gonna be dealing with 3 hot legs. Could be a high leg. It could and the neutral as well. And like I said, when we go into that, we'll designate this bottom as neutral, and you'll have 3 hot legs, you know, up here to attach to. Okay, we good with a single phase transformer? Okay,
Yep.
no?
Yeah.
Okay,
Okay.
all right. If you have any questions, let's talk about it now. Or we can talk about it anytime, but now's a good time while we're all together. Okay, all right, well, I'm gonna go into another one here. And we talked about, don't say that. All right, just like we talked about in the, on the film there, the video we watched with Transformers, this Transformers, the primary comes in, goes through the bushings, goes out, grounds to neutral. Comes into primary on this side, goes through windings, instead of going out of, you know, a bushing on the top, it actually goes out through the bottom. It's connected to the tank, and the tank is grounded. We all got that correct? It's the same flow, and the secondaries, they will do the same thing on each one. Okay, we won't talk about the one on the right probably anymore, but just wanted to show you the difference. It's the same thing, but it's just configured different. Like Professor Shoemaker said, different companies have different standards for their transformers. The outcome is the same. All right. Now, what we talked about a minute ago, who asked the question? Joe, was that you asked about transformer banking?
Yes, sir.
All right. That's transformer banking. That's a lot of stuff to look at. It's like I said, at the top over here, you've got 3 phases, A, B, and C. You've got A, B, and C on the secondary side, and you just bank these transformers together. Don't pay a whole lot of attention to that right now. I just want to show you, since he said that, I just made this up the other day. And we'll actually get into this in a few days and show more of the transformer, teach you guys how to bank it, and then we'll give you some tests and some drawings, and you can bank this stuff out yourself, okay? So don't let that blow your mind. You'll get it. Guys, you got any questions about this before I close out of this transformer part?
No.
Okay. All right. Let me get out of that. I think I'm gonna keep this thing shared for right now. If you can look in your book on page. We're gonna go look at auto transformers now, and that's on page 340 in your book. If you want to look at it, and what it says in the first paragraph on auto transformers, it says auto transformers are 1-winding transformers. They use the same winding for both primary and secondary. Figure 13-24, the primary winding is between points B and N, and has voltage of 120 volts applied to it. That's just in the book where they're applying 120 volts, okay? And what an auto transformer does, it has 1 winding. What it does out in the field, and we call these voltage regulators, and I'm gonna show you this video in just a minute, but a voltage regulator, somebody tell me what it does, what we talked about before, maybe the other day on voltage regulator.
Just keeps the voltage on the line within the 5%.
5%? What, I mean, is
It takes a higher low voltage, and it offsets the plus or minus. So if the voltage is too low, it'll maintain it at a plus value. If it's too high, it'll maintain it at a negative value.
That's right. That's excellent. That's exactly what it does. And I'll give you an example of that. Part of my service territory out of Kings Tree, I had to serve a little small town outside of Kingstree, maybe 15 miles away. It's Greeleyville. Some of you might know it, but that is a right good distance away from the sub. And the feeder that was feeding that town, with all the tap lines in it and all, they said it was one of the longest feeders on our system. And they said it was right at 100 miles of line distance. And Greeleyville was at the very end of that line. I'm not saying Greeleyville is 100 miles, but line miles, we had one part of that feeder coming toward Andrews, one part going toward a little community called Lane, and then another branch of it off fed the town of Greeleyville. And all three of those combined line miles, well, it was right at 100 miles, but Greeleyville was the very furthest part out from it. And we knew that we had trouble with regulators when customers call in and say, hey, my lights are very dim. My stove won't heat up like it's supposed to. My AC unit is humming real loud. Those are problems with low voltage, and we knew right where to go to. We'd have to go to the regulator, check the settings, and then, we'd have to raise or lower it. It's supposed to be done automatically, but sometimes, this man-made equipment, nothing's perfect. So we'd have to go out there and operate this regulator to get it to the right voltage level for those customers at the end of the line. Very important piece of equipment. It works in conjunction. Sometimes the engineers, they'll figure it to work with some kind of capacitor banks or something. We'd have those on the end of the line as well toward there. If a thunderstorm came through and one of the fuses blew on the capacitor bank and the customer's calling, we'd have to go check that as well. But anyway, voltage regulator was the main piece of equipment that we dealt with as far as, making sure that voltage stayed at its proper level. I'm gonna take a minute here. This is a short video, and this talks about the voltage regulators. Can you guys still see my screen?
Yes.
Let's begin by taking a look at a single-phase step voltage regulator and see how it is installed in the system. The tank of the regulator has 3 bushings on its top, one for the connection to the line, one to the load, and one to the pole ground.
All right, and that is very true. On the top of these regulators, you see 3 bushings on top, and when it says line, that means the source coming in. And you might have an L up there on top of that. That's the load side. And of course, the 3rd bushing goes to the neutral or the ground.
Surge arresters are connected to the line and load bushings. This dial, called the position indicator, is mounted on the tank so that it can be viewed from below. The dial has a scale, which has a 0 or neutral position in its center. Additionally, there are 32 marks indicating the 16 steps above and below the 0. All
right, just like I think Capezzi said a minute ago, I think he's the one that mentioned the steps on it. There's actually 16 raised steps on this regulator, and there are 16 lower. The voltage gets too low, then these arms right here, that yellow arm, it'll start moving down to the right. If it's on 2 there, then it's going to bump up to 8 if it needs to. And the cool thing about this regulator is it has a time mechanism inside it to where if it goes up to raise 4, R4, which would be to the right side, and all of a sudden the demand has dropped down, or the amps have dropped down, the current's dropped down, it's not going to automatically just drop that voltage back down. It's going to give it a few minutes to settle down before it says, hey, okay, voltage is too high. I need to step it back a little bit. And that's a very good feature on these things. That way people don't see their lights flickering up and then it's not all the time raising up 4 or 5, steps up and then automatically dropping back down you know, it's kind of keeping it at a constant, and it's a slow process up and down. It's watching and monitoring what's happening. As this goes up, and you'll see me talk about it in the video, the little hand to the right of the yellow, that marks the highest position that that regulator has been to. And on the left, if it's lowered, it'll tell you how many steps lowered it's been in the past. There's a control box below this regulator on the pole. It has a reset button inside it. To whenever these regulators, we used to go check them monthly. A part of our checklist, we used to have to go out and check the line capacitor banks and regulators. And actually once a month, we would notate where it was at in the raised position, where it had been on the lower position, and we would reset it, and engineers would get those cards back and they would monitor. But it's all done, I think, electronically now, and they can actually go into the system and pull each regulator up by pole number, and they can check these things now. And they should be able to, with, you know, technology as sophisticated as it is today, you know, they could go in and change these control settings or whatever sitting at a computer somewhere. So a lot of this stuff that we used to do hands-on is done from somebody's desk now. Guys, you got any questions about the raised and lowering of the voltage on here, the windings? I'm going to continue on.
The pointer indicates the present tap position of the regulator. In addition, there are two drag hands, which indicate the highest and lowest tap positions that the regulator has moved to since the drag hands were reset. In the tank, oil is used as an arc extinguishing medium. An oil level gauge is located on the tank of the regulator so that the level of the oil can be checked easily. This voltage regulator has a solid-state control mechanism mounted in a metal box lower on the pole. It is permanently attached to the regulator by a control cable. When the regulator is changed out, the control mechanism and cable are changed at the same time. The control mechanism permits the voltage regulator to respond automatically to changes in line voltage. The control mechanism can also be used to operate the regulator manually. The mechanism is powered by a fused 120-volt source. Here, the voltage regulators for each phase have been mounted on separate poles. The phase is broken by inline insulators at the pole, and the regulator is connected to each side of the phase through a pair of permanently mounted disconnect switches and a bypass switch. In this case, the switches are mounted on a common base. However, other methods of connecting a regulator to the system may be used. Normally, the disconnect switches are closed and the bypass switch is open. This feeds power from the line side down through the voltage regulator and then out to the load side. When the regulator is in the neutral or zero position, the unit can be taken offline by closing the bypass switch and opening both disconnect switches.
Now, that's a very important thing to remember when you're working with voltage regulators. What he just said about it being in the neutral position, you do not want to try to bypass this regulator if it's in a raised position, like raised 1, 2, 3, or 4, or lowered 1, 2, 3, or 4. You want to make sure that that regulator is in that neutral position, because you can cause, if it's not, it could cause a short inside that, across those windings in that regulator, and you could have a catastrophic fault. And you don't want to be anywhere near that baby if it blows up, it has a fault inside. That is one more big bang. There's actually 3 ways or 4 ways you can detect if this regulator is in the neutral position. And I'm gonna back this up. All right, come on. Right here. You can't really see it well. I'll show you another video in just a minute, but you got to make sure this indicator, that yellow hand, is straight up. There's an N up there. Make sure it's on the N. That's one way you can look at it. Also, in that control box, they don't show it in the control box, but inside that control box, there is an indicator light that when it gets on that neutral position, that indicator light will come on. The third way you can look at it, you can actually look at that mechanical indicator back up on it, and you can count the steps. As this you're operating it back to neutral out of that box. You can actually count the steps back till it gets to neutral. Last way that a lot of guys use, and it's probably the best way to do it, is there's a meter that you can use to put between the source and the load. And it's on the end of a stick. I'll show you it in a video in just a minute, but it lets you know when the regulator itself is in a neutral position. And you want to make sure that one or all of those three methods are used, because you don't want to be in the bucket above it and it's in the raised one, and then you open that bypass up, because it's going to be a bad day, or close that bypass and it's going to be a bad day for somebody. So make sure that you've got that closed, and when it's in a neutral position before you open up these as well, because what you're doing is you're breaking load on that feeder. Any questions about the regulator, what it does, how it works? Like I said, there's a schematic in the book on page 340 if you want to look at that. These are excellent pieces of equipment in the field to use. Worked on them a lot. They're in substations as well. Any questions about this before I play the next video? This is actually a video of a crew changing out a regulator. If I can find it. Give me 5, guys. That's not it. That's not it. Let me see. It's a cap bank. Is it raining over there with you guys today?
Yeah, it's raining now.
Yeah, it's
Yeah, it's
raining
rained
a
a lot.
Yeah, we're gonna skip the I don't know what I did with it. Let me search. Let me try one search before I roll top inbox. Let's see. Hang on one second, guys. Yeah, we're gonna skip going out to the field today. Yeah, we're gonna skip going out there today, guys. It's just gonna be too wet. This one right here. I think this is it. I may speed it up a little bit just to get it through some parts, but let's watch this real quick.
Well, once again, I am Jim Dukar with T&D How Videos. Today, we are going to be watching a voltage regulator changeout in the Arizona desert. Our participating utility is Arizona Public Service, and this video is sponsored by Burns and McDonnell. Now, the voltage regulator is the cylindrical white device at the top of this pole that the guy at the bucket is addressing. What a voltage regulator does is it controls line voltage in smaller corrective steps than with a capacitor. And in fact, the voltage regulator holds line voltage within predetermined limits, and in that way assures proper operation of customer equipment. This regulator also allows for up to 2% efficiency increase on this line. And what you're seeing here is our line crew using a regulator neutral detector, an RND, to detect current on the line, make sure it's at neutral so they can do the work.
Down
And now that he's at,
All right, guys, that's the piece of equipment I was talking about, the meter that they use. They go in between the two bushings to make sure it's in neutral. And I want you to notice one thing, and we commented about it, especially when you're up the pole changing transform, whatever. These guys communicate with the ground right good bit to make sure they're doing things right. They're communicating with the foreman to make sure they're, you know, at the right steps. Somebody else is going to be listening to make sure that these things are going right, because you don't want to miss a step with this with it energized.
I got a question, sir.
What's up?
It looks like he's not even wearing rubber gloves. They look like they're leather. I mean, is that
Those
standard practice?
are the leather protectors over the gloves.
Oh, okay. I got you.
I'll let him tell you a little more about the switch itself.
I'm going to point right here. This is your bypass switch, and it's slung into this position, which tied these two together on the top of this, thus bypassing the regulator. This is open now, so it's isolated from the top here.
And next we're going to see them install what is called a MAC, short for a mechanical jumper, over this line so they keep the line energized while they're doing the work. This jumper will simply replace the traditional jumpers between the switch and the line.
Yep. How's that? The reason you don't want to put this on with this switch closed in, because when the regulator's online, you'll get circulating current. So right now, the regulators, as you can see, is offline. We don't have to worry about that.
And now with that MAC or mechanical jumper in place, they can go ahead and cut away the traditional jumpers from the switch up onto the line, because they will be replacing this switch as they replace the voltage regulator to the right on the screen here.
Okay.
Cut away both of the jumpers.
Yes, sir.
And then it's time to add some line blankets, protection. Cut away the jumpers to the bottom of the switch from the voltage regulator. Now hook up the switch to take it down.
Swing, Kenny.
And next, take that switch
Okay,
off
we're good.
and to be lowered to the ground.
Back slow.
And
Hardwired.
next, they're going to go back. This is the voltage regulator, and they're discovering that it's hardwired. So they're going to have to bring the old control box up. See them now. You see two men working. One is on the bottom of the pole, releasing that control box, and here he's pulling it up through the wires to get it free. And now you see that control box coming up. He's going to tie it to the voltage regulator to be taken down. Here we're bringing the boom up to attach to the voltage regulator, and here they are disconnecting it from the pole. Again, they've got it secured to the boom truck. So as it breaks free from the pole, they've got it harnessed to the boom. Bring that down.
Looking good.
And now we'll see it swing around on that boom. And the old regulator will be taken away by truck. And right next to it is the new voltage regulator. So they're now going to hook up to that same boom and lift that up to the pole. See the lineman here in the bucket guiding it into the pole. And then you're going to see him set it on its new braces. And as they set it in place, I'll let you listen to the conversation between the guys up in the bucket and the boom operator on the ground.
Winch off. A little more. Oh, right there.
And now we're going to see him tighten down that new voltage regulator onto the pole, and then secure the controls from below onto the new voltage regulator. Next, they're going to lower the bucket and go back down to ground to pick up the new switch that is being replaced also. You see that being lifted up with boom here. But they're actually going to encounter something of a problem here that's too tight, so they have to lower this switch on the pole. And pay attention here, something happens, you'll see at the end of this video, that means we're going to jump now to where he's installing a communications antenna. The switch has been installed, you can see it up there, but he's installing a communications antenna, and then he's going to do the ground wires or the new voltage regulator. And in fact, here attaching the case ground to the system neutral. And next, install some clamp top insulators to the pole, and those support the regulator leads. You see him feeding those now through the clamp top insulators. Next, he's going to tighten some torque bolts on these clamp top insulators. They have to be tightened to between 75 and 85 pounds of torque. And so what they do is tighten them until the eyes actually break off. Next, you're going to see him strip the end of one of these jumpers and then make the connection into the lower plate of the switch here. Good view of that as he's connecting up to the switch. Next, we will see the installation of a bird guard, a plastic protector, so the birds don't damage the lines, vice versa. And speaking of birds, now we're going to go back up to the top of the pole and replace this cross-shaped raptor perch. And I'll let them tell you a little bit about it.
This one right here is good for a pterodactyl or anything.
Yeah.
You don't like that. Yeah, it's kind of got that rustic look.
Actually, the reason to replace this is the smaller curved surfaces are thought to be better for the birds to rest on.
It's right in Cave Creek, Arizona. Is this going to be your source straight up? Yep. That's the way I see it. Okay. Feeding it in, Kenny. Let's see if we can go on right out there. Happy with that?
You'll notice when these guys start working on the primary side of this equipment that they have a whole lot more communications, so they can verify with each other that they're going on with the right end onto the right conductor. That's very important. You don't want to back this thing up or hook it to the wrong conductor up there. So especially if you've got more than one phase of wire on the pole.
I want to pull this open, Kenny. I think we should. Gotta come open before you land. Okay. That's in the clear. That way you're bypassing the regulator to the.
So thought that was good and valuable to listen to the linemen talk about what they were doing up on the line. Next, you're going to see them connect the regulator leads. And what he's holding here is called a power cap. And we're going to see that landed on the line in just a bit.
All right.
And next, what they're actually doing is stripping away a small piece of the insulation around this wire so that they can get a regulator neutral detector in there later to check for voltage without having to go right to the voltage regulator itself.
Perfect.
Now they're going to land the leads. So let's listen.
All right, we're going to land these. And like Kenny said, the bypass is closed. So it'll be hot on both sides. You got a lot of control. Land this in first when you're ready. Go for it. Mine's in the clear. Okay, coming on. Perfect. Hold tight, bud. Hold tight here. Taking the jumper off. We're landed. We're landed. It's bypassed.
More communication.
Gonna pull the jumper. Pulling the jumper. Bypass is closed.
They're taking off
Coming off
the
the
mat.
mat. Coming off the mat.
And so you can see that here they are indeed coming off with that mat. Each side lifted up and out of the way. And the remaining task will be to simply close the bypass switch. Close the switch, which he's going to do here with a hot stick. And once that switch is closed, we have the connections between the line and the voltage regulator. The MAC is off. And with that, you have seen our T&D How video on a voltage regulator changeout.
All right, who made the comment about the rubber gloves to start with? Was that Mike?
That was me.
Yeah, you're right. I thought that those were the leather protectors, but they were actually up there with leather gloves, operating sticks, and that is a big no-no. You don't do that. Rubber gloves, you have to wear your rubber gloves, especially if you look on the end of their boom. They've got several sticks attached to the end of their booms. If they leave that stuff on there every day like that out in the weather, it's going to be exposed. It's going to be dirty. Voltage could track over on this stuff. So, no, you do not want to be wearing leather gloves, especially I noticed that they were working up around the primary on that big switch up there as well. No leather gloves. You want to keep it, especially the one guy, I think he was on the right-hand side bucket. He did more.
I mean, he had bare skin exposed right next to the switch.
Yeah, you don't want to do that. No, you want to make sure you're protected. Wear your rubber gloves always. You don't want to put yourself in that situation or your buddy or anybody else, because anything can happen. So anybody got any questions about regulators? They're auto transformers, what they do, how they raise and lower voltage. Just remember those things. You're probably going to get a quiz today in just a little bit on this stuff about regulators. We'll split it up between the regulator and this little single-phase transformer. It shouldn't be too hard. Just remember those things about your steps, raising and lowering steps, and the switch and the bypass. What position does the regulator need to be in before you can close the bypass, those kinds of things. So questions, comments on any of it before we end this meeting? And
I'm pretty comfortable with it.
Okay, let me hang on a second, guys. Could y'all see that video pretty good?
Yes, sir.
All right, let me get back over.
Yeah.
Oh man.
What'd you call it when before you use a bypass switch? The voltage regulator has to be in what? Neutral?
Neutral position.
Neutral, yeah.
Neutral position.
Yes.
That yellow one's got to be in the center.
Yeah.
All right, what's going on with this thing now? It will not let me unshare my screen. Jeez. Yep, that'd be the neutral position. That is correct. I'll figure this out in a minute when we're done. The let's see, our transformer. Has everybody got with Mark Jones about your payment method for your tools?
Yeah. I have.
Everybody, the sooner everybody does.
Yep, I have.
Okay.
Mine's a little sloppy, but I'm trying to get my VA in the school in the same sheet of music to get the stuff paid for. But it is what it is at this point.
I got you. Well, just guys, as soon as you can do that, do it as quick as possible, because he wants to make one trip and one trip only to bring things down here. Just make sure you got everything's in line so we can go ahead and get your tools and y'all get comfortable in it. And like I told some of you guys on the field, some of those old tools we got, they're there for you to use, and it's kind of rough at times with those things. It hurts your legs, it might hurt your back, but you get these new tools and it'll be a world of difference climbing. So make sure you got it right before he comes. All right. Any questions or comments? Anything else before we end the meeting this morning? I appreciate everybody being here today and participating, and hopefully tomorrow it will not be raining in the morning. If it's clear in the morning, we'll go out to the field at 8 o'clock and work till about 12. We need to get out there and do a little climbing. We ain't done much this week, so we'll get out there tomorrow, get you climbing. I'll get you back in the groove this week. If you guys need help, the guys that hadn't done the transformer yet, if you need help up the pole, I'll be glad to get up there with you, walk you through it. Even anybody who's been up there that wants help up the pole, I'll be glad to get up there with you. I know Professor Shoemaker, he don't mind either, or if you want help on the double arm or single arm, we'll get up there with you and hang around and make sure you're doing it right. So, but,
I'm out of town all weekend.
Say again?
I'm out of town all weekend.
You're out of town?
All weekend, yep.
You're leaving when, today?
Yep, at noon.
Okay. All right, well, just be safe and come back. You know what I'm saying? We'll look for you maybe Monday next week. Hopefully all this rain's going to get out of here. It's been a really wet week. And we can get back on a normal schedule out in the field. Okay. Anything else? We'll send out a remind message about the quiz when it's available. We'll send out a reminder about it in the morning about the class, if we're going to go or not. And then, of course, we'll send a reminder for next week. So, and I'll be hanging around here. Not sure, Professor Shoemaker, he'll be in and out. So if you guys got any questions about anything that we've done so far, just feel free to contact us and let us know.
I had a question about something not video related, sir.
What is it, Joe?
I went on yesterday. I went ahead and updated my resume, and I was going to try and fill out a couple applications with the local power companies.
Right.
And everybody that I went to, there's no job openings at all. They've locked everything down.
That's right. I contacted last week some of my supervisors at Duke and manager and all, my old manager, and they're still not, the job openings are still there, but they're not doing anything with them until this COVID stuff. You can probably look into next month, maybe August. I mean, right now, South Carolina's kind of getting an uptick on the COVID, especially in the Myrtle Beach area. And they're looking this thing again. And of course, you've heard rumors that that the fall, it could have a comeback when it starts cooling off. So guys, I really don't know when. They're not saying when they're going to be hired. Of course, some utilities since got a message week before last about they needed some guys, some crew members.
Yeah, I checked out Sumter too, and they didn't have anything listed either.
Yeah. And let me ask you guys a question. Do you all just want to kind of stay around in the Myrtle Beach area, or
I
It
was
don't
looking
matter
at
to me.
I have to.
Yeah, I'd like to stay in Myrtle or proximity.
Of course, you got a bunch of different companies still in this area, but also go on the Pike Utilities website. They've got openings, or they had them last time I looked at them a couple of weeks ago. There was a bunch of openings in the Rock Hill, Charlotte area. There was a bunch of openings up near Greenville, Clemson, in the upstate part. They were looking for a bunch of help up there. So if you don't mind moving, relocating, if you don't have no ties to the area, search out in those areas, look around. There's still stuff open, but Myrtle Beach is, and in our area, this part of the state, they pretty much got things tied down with Duke as well, with Santee Duke. And they're really not doing much hiring because they're scared. They're kind of scared to hire somebody in there that might have that COVID. So you don't mind relocating. Of course, Joe, you got the buddy that does the helicopter lineman, right?
Yeah, it's my cousin.
Yeah, your cousin. So, there may be opportunities out there for that. One of the guys in the first class I was with out here, I think he's out in Colorado, Wyoming. He's working on a wind farm out there. So
I don't know that I'd be able to jump straight into that to help him out, though, because he's a Class A journeyman.
Yeah. Well, whatever steps necessary it takes, contact us. I know Air One is in our area. You might want to look at their website.
The Air One.
Air One.
All right.
Yeah, that's matter of fact, I think a guy from a transmission lineman from Duke actually started that years ago. But check into it. Just just don't stop in your area. I mean, if you don't mind going maybe down to Charleston and work for Dominion or something, that's not really too far away from Myrtle Beach or your area. But jobs, they do get saturated at some point, and it may be a while. Or check with the telephone companies and see what they got, and just don't limit yourself to one thing. So anyway, that's my spiel on that. Any other questions or comments? If not, guys, it's 10:45. We covered pretty much everything we need to cover for today, and we'll go ahead and end this meeting if there's not anything else. Appreciate you being here.
Plan for field at 8 tomorrow.
The plan, yeah, you'll get a reminder on it if whether we do it or not. So we'll let you know. If the weather report don't look good, then we won't do it. We might have to come online for a few minutes in the morning and jump into something else.
Sounds good.
We'll let you know.
All right. Have a good one.
All right, buddy. Thanks. Appreciate y'all being here.
Take it easy.
Take it easy. Okay. Can't hear you. There it is. Stop share. And